All right, question number 18. And the question asks, without using a calculator, find the absolute maximum and absolute minimum of this. So to start with, we're going to do a table of values. We're going to start with the n values, which are -3 and 0, and then plug them in. So -3 plus 2 is -1, but the absolute value is +1. Plug in 0, the answer is 2. And then the critical numbers. Now, we already did the critical numbers for this back in question number 8 or so. It's where the derivative is undefined. So it's a v. The vertex is at -2. So if I plug -2 in, you get the answer 0. So the absolute max is 2, and the absolute minimum is 0. Number 19. All right, so this is from -3 to 1. So we start with the n values. If I plug them in, I get what? -15 and -3. If I take the derivative here, this is really 3x, take away 6. So the derivative is 3. There are no critical numbers here. So if I make it equal to 0, there's nothing that makes it undefined. So we have no critical values at all. So this is it, what you see. So the absolute max is the y value. That would be -3. And the absolute minimum is -15. Number 20. So x squared over x squared plus 2 from -1 to 2. Table of values. So -1 and 2. Let's start there. -1 gives me 1/3. 2 gives me 2 over 6, or 1/3, right? Both give me a third. Is that right? Yeah. No. So that's 4. No, it's 4 over 6. That's 2/3. Then I got to take the derivative. That's the bottom times the derivative of the top plus the top times the derivative of the bottom, and then the bottom squared. Now, what values make it undefined? Now, what makes this undefined? There's nothing here that makes this 0. So all numbers work. In the numerator, what makes the numerator 0? So I'm going to factor out, I'm going to make it equal to 0, just the numerator. I'm going to factor out a 2x. And I'm going to be left with x squared plus 2 plus 2x. So this gives me the answer 0. This doesn't have an answer, ultimately. It's imaginary. So x squared plus 2x plus 2 is not factorable. And if we try to solve it, you'd see that there's imaginary answers to it. So the only critical number is 0. Did I do something wrong here? X squared plus 2. So I factored out a 2x. I was left with x squared plus 2. I did all kinds of things wrong. This should be a minus. And when you factor out a 2x, you're left with x squared. My goodness. And then these cross out. And you're left with 2x times 2, or 4x. Anyways, either way, the answer is still the critical number 0. Yeah. So we're going to use 0. If I plug in 0, the answer is 0. And now looking off of here, what's your absolute max? And then what's your absolute min? Oops, 0, right? So the max is 2/3 and the minimum is 0. All right, 21. This is the trigonometry one we did before in part 1. So I'm not going to redo that. So if you go back to question number, is it 9? Yeah, question number 9. You can see what we did. So we got to use the n values, which are -3 and 1. Oh, sorry, -3 and 1. 0 and 2 pi. I was thinking, how am I going to do that? 0 and 2 pi. So if I plug in 0, the value of cosine at 0 is 1, and 1 squared is 1. This is 0, so it's 1 plus 0, so it's 1. 2 pi would give you the same answer. And then we found values at pi over 2 and 2 pi. So we're going to put 2 pi over 2 here. The value of pi over 2, cosine is 0. Sine of pi at pi over 2 is 1. So the absolute max and the absolute minimum is the same number. All right, let go of the trigonometry right now. 22. All right, we have a piecewise. And it says from -1 to 8. So we'll start there with -1 and 8. So if I plug -1 in, -1 is less than 0, so we plug -1 in here. -1 squared is 1, but we have a negative in front, so it's -1 plus 2. 8 is greater than or equal to 6, so 8 belongs here, so the answer is -4. Then the derivative So when I take the derivative, if we don't have a variable, we can't solve for when the derivative is 0. I guess the derivative is 0 all the time when it's greater than or equal to 6. So all numbers between 6 and 8. But all numbers between 6 and 8 give us the same answer. So I don't need, like 6 gives me the answer -4, 7 gives me the answer, all numbers. So I'm looking at the y value, so I already have -4 to look at in 1. Here, the derivative here, if I make -2x equal to 0 and solve it, x equals 0 and it's in my restriction. So I need to include 0 on this list. So 0 belongs here. And if I plug in 0 into the top piece, the answer is 2. And then what's the absolute max? So the absolute max is 2. And the absolute minimum is -4. All right, 23. We're done with those kind of questions. Find the absolute minimum and values of the functions graphed here. So the absolute minimum here is 0 and absolute maximum is 3. just looking off the graph. Number 24. The absolute minimum is 0, and we have no absolute max because it goes up to infinity. Number 25. We have an absolute minimum at 0, but we have no absolute maximum because there's a hole there. Number 26. The minimum is at 0 and the maximum is at 2. Easy, right? Number 27, true or false? It's a 50-50 guess, right? The minimum of a function on a closed interval can occur at 2 different places. It's true. There could be a tie, right? So it could occur at 2 different places, and it's fine. Every continuous function has both a maximum and a minimum on a closed interval. If it's continuous, the answer is true. It's when we have holes and asymptotes that things change. The functions f at x and g at x. So f at x and g at x have the same critical values. That's because the derivative of g at x, because the derivative of any constant is 0, so these derivatives match. So yes, that would be true for 29. The functions that have the same critical numbers. That's not true. So if I take the derivative here, it would be the derivative here, and then times the derivative of the inside. Anyways, that does not equal this. These are not the same. This one's false. Number 31. We're using the mean value theorem. From 0 to 1. This is continuous and differentiable from 0 to 1. So I plug in, take the derivative, and then I find the a rock, and then I make them equal to each other. So that's f at 1 minus f at 0 over 1 minus 0. If I plug in 1 to anything, the answer is 1. 0 gives me 0. So if I do all of that, the average rate of change is 1. Then I make them equal to each other. And then solve it. So to undo the 2/3, you multiply by the reciprocal. And then x to the negative 1/3 is really 1 over the cube root of x. And then to the exponent 3. So I got 8 over 27. I'm just making sure that's right. It is. When solving it. Number 32. the mean value theorem, the derivative in AROC, it must be continuous and differentiable. It is not continuous at positive 4. That's in the middle of my interval. MVT does not apply. So it's not continuous at x equals 4, so that's why it doesn't apply. Done. 33. So there's a discontinuity at 0. 0 is in the middle of this interval from -1 to 1. So again, the MVT does not apply. There's a discontinuity at x equals 0. So that's why it doesn't apply. 34. Alright, this one is continuous and differentiable. So it does apply. The derivative, that's the easy part. AROC, set it up. So there's the average rate of change. 2 squared minus 2 times 2, that's 0. Plug in 0 and the answer is 0. So this is 0. Then take the derivative equal to 0 and then solve it. So at this value, AROC, the average rate of change, is equal to the instantaneous rate of change. 35. I'm sure when you see trigonometry, you might be hoping that it doesn't apply. Sine is continuous and differentiable, so it does apply. So the derivative is cosine x. And then we have to find make it equal here, the average rate of change. So we're going to make them equal to each other. If I plug in pi, the value of sine at pi, it's here on the left. The y value, it's 0. If I plug in 0 for pi, it also has the answer 0. So 0 divided by pi is 0. And then the question is, what angle gives you the answer 0 for cosine? And that's right here at pi over 2. At pi over 2, cosine is 0, and that's your answer. $36. This is your lucky day. This does not apply. There's a discontinuity at pi over 2. So the value of tangent at pi over 2, if you think of the unit circle, again, up here, it's y divided by x. So 1 divided by 0 is undefined. So there's a discontinuity, there's an asymptote in the graph here in the middle of my interval. 37. And this is, we may use a calculator. That's very nice. So f at x equals x cubed subtract 2x squared plus 3 from -1 to 2. I'm going to take, for the mean value theorem, the derivative and the A rock, and then it says I can use my calculator, so why not? So how would I set this up to be as efficient as possible? So this is what I would do. You gonna focus? I would define it in my calculator. So I would type in x cubed subtract 2x squared plus 3 then I would come back here and I would set up an equation to solve. And my equation is the derivative of what I just typed in, which is f1 at x, equal to and it's f1 at 2 subtract f1 at 0, no, f1 at negative 1, and then 2 subtract negative 1, and then go comma x at the end. And it gives you your answers. Now be careful. The interval is from negative 1 to 2. So I'm looking at the right one. So make sure your answers are between negative 1 and 2. They are. So make sure you have all of them. So negative 0.215. The other one is negative 1.548. Well, that's beyond my interval. Is it positive? Oh, it's positive, so that's good. So positive 1.548 is in my interval. And then there's still one more. Or is that it? Is it only the 2? No, it's just the 2. That's it. Those two right there. That's the setup. Good practice. We can do it again. 38. Let's go through the steps again. Isn't it nice to know how to use your calculator? It comes with practice, like driving a car. Here we go. So let me go through the steps of that function and what would I do to find it. So first of all, even if you use your calculator, you should still show what you are doing. So we're taking the derivative equal to. So it's the derivative equal to the A rock, and then we're going to write down the answer using our calculator. Okay? So let's do that together. Just so you know, there's a discontinuity at positive 1, but positive 1 is not in my interval, so it's fine. It's continuous and differentiable. So let's go through the steps again together. So I want to first define it in here. Seeing if it'll clear up a little bit for you. So come back here, erase this, and then put in the function 1 over x minus 1. Then come back here, and we're going to solve an equation, and we're going to do the derivative of f1 at x equal to a fraction line, f1 at 3 subtract f1 at 2 divided by 3 take away 2, or 1, comma x. So I get the answer is negative 0.414. That's not an answer because it's not in the interval. The interval is from 2 to 3. So the other answer is between 2 and 3. So the only answer is 2.414. That's it. Anyways, are you starting to have those skills with the calculator, that if you're allowed to use it, that you have some skills to use it? 39, let's do this with trigonometry. So we have a function, 2 sine x plus sine 2x from 0 to pi. I'm going to show you another step that I could have done for the last ones too that will be helpful. So let me show you here with trigonometry. So we are going to take the derivative and then we're going to make it equal to the a rock. So that's what I'm going to type in. Alright? So let's take out our calculator, see if we can do it together. I'm going to add one step, which is the domain restriction with this calculator. I'll show you in a second. Alright. So step number 1, we're going to go back here like we're going to graph it. Press tab. Erase what we had before. And then we're going to put in the new equation, which is 2 sine x plus sine 2x. Double check. Did I type it in right? Press enter. Fun looking graph. Come back here. And now we're going to solve an equation. Menu algebra. Solve it. What am I solving? So I want the derivative of f1 at x, what I just typed in, equal to f1 at pi subtract f1 at 0, and then in the denominator pi take away 0 is just pi, and then we want to solve it for x. Alright, so here's an extra step for a domain restriction. We're going to press control and equals. Control and equals. And then we're going to go to this line right here and press enter. And then we're going to put in the domain restriction, which goes from 0 to pi. So I'm going to go 0, press control equals less than or equal to x, control equal less than or equal to pi. So we put a restriction in from 0 to pi. So when I do this, only the answers from 0 to pi are going to show up. So one answer is 1.0. And 3.1415. I think both work. Anyways, 1.047. And really the second one's just pi, right? 3.14. And there's your two answers. And learning how to put a restriction in with your calculator, then you don't have to think whether I need to cross it out or not. The calculator's doing the answer within the restriction. One left. And then the assignment's over. You ready? The height in feet of an object at time t is given by this equation. And the question is, find the average velocity. So the average velocity from when? First 3 seconds. So that's a rock. So that's h at 3. From the first 3 seconds is 0 to 3. If I plug in 3 I'll be out there. That's 56. If I plug in 0, it's 200. And then if I divide that through, you can use your calculator, it's negative 48. And the units are feet per second. That's the average rate of change. Part B, the mean value theorem. Find the time at which the object's instantaneous rate of change equals the average rate of change. So I need to take the derivative and make it equal to negative 48. I don't need a calculator. Divide. 16 does go into both, though. At what time does the average rate of change equal the instantaneous rate of change? And it's at 1.5 seconds. All right, we're done. Mr. G Math over and out. I am so proud of you that you do your work and do your best. Till next time.